All right, this is our last section of Unit 10. Per usual, last section means word problems, right? Applications. All right, so 10.5 real world triangle problems. What we're going to start off with is example number 1. Example number 1 is for you guys to walk me through it. If you did your do now, then that was to get your mind going and thinking about how to solve example number 1. Okay. All right. So it says here, Calvin Butterball is waiting outside the school building for his trigonometry test to begin. He observes that the flagpole is casting a shadow on the ground and decides to calculate how high the pole is. He steps off the shadow, finding it to be 22 meters long. From an almanac, he finds that the sun's angle of elevation is 38 degrees. How tall is the pole? Okay, so someone tell me, what is the first thing I should do to solve this problem?
Draw a picture.
Draw a picture. And I'm gonna draw a picture of what? What kind of triangle? A right triangle. So I have a picture of an almanac is a book that collects data of what's happening from year to year. There's sports almanac, there's weather, there's location, but it collects the data of what happened over the year. So like there's the farmer's almanac to say how, but you can download it. You can go to a website, look it up. All right, but anyways, I have the right triangle. Now, what's next?
You put it in your angle.
Okay, where's my angle?
The top one. Is it the bottom one?
Why? Because it's what?
Is it like the angle? Oh, because it's casting the shadow. The sun's elevation.
The what?
Is it like it wouldn't be up here, but
That's the depression. That's the angle of depression. Yeah.
Yeah.
So we're at 38 degrees, right? All right. What else?
We need to know that the ground is 22 feet.
The ground is 22 meters. Got it? And what are we looking for?
How tall the pole is.
We're looking for the pole, right? All right. So based on your do now, dun, 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 dun. See those connections right there? If you did your do now, based on your do now, what is the most direct way for us to solve this?
Maybe 10.
Why would you say tan?
Because we have the adjacent and we're never mind.
Yeah, keep going. We have our
for the opposite.
There we go. We have our adjacent and we're looking for our opposite. So therefore we would use tan of 38 equals our opposite, which is our pole, over our adjacent, which is our shadow, which is 22 meters long. Okay. All right. So how do you calculate the pole? What do I need to do? Multiply both sides by 22. So 22 tan of 38. So approximately how tall is this pole that Calvin Butterball? So we're going to say 17.19 meters. All right. Yes.
Yes.
Okay, so a lot of times what happens is when you have word problems, you guys automatically think it's going to be a hard problem because of the words.
Yeah.
Okay, but
it becomes a reading test.
it becomes comprehension. That's what the focus is on. Okay, comprehension. All right. So once you comprehend, was the math that bad though? Yes. No, it wasn't. Okay, so a lot of times your word problems are actually your easiest problems on the test. You just, question 2 is not hard. It's just a lot of words. All right, here we go. Question 2, it says, as a ship sails into harbor, the navigator sights a, is it buoy? At an angle of 15 degrees to the path of the ship. The ship sails 1,300 meters further and finds that the buoy makes an angle of 29 degrees. So out here, you see this little, we're gonna put a bee floating around, right? Huh? Okay, it's just floating around. And approximately, I'm this little ship down here. Ship. There's my ship. Y'all get on my nerves. I'm right here. And my angle, I'm looking at it at an angle of, I'm on there, it's gonna be an angle of how much? 15? So from here to here, I'm at 15 degrees. Okay, that's what the first thing tells me. It says then I'm gonna sell how far?
1,300 meters.
So I'm gonna sell 1,300 meters. And after I sell, I'm gonna stop here. Well, now this is my second stop. And now what is it at?
29.
29. So now it's at 29 degrees. That all got jumbled together. Okay. All right. So that's where we're at. Okay. Now, part A is saying how far is the ship from the buoy at the second sighting? So part A, we are trying to figure out this distance, right? This is what A is asking us. Do we understand that? Okay. So A is asking us to find this. Do we have enough information to solve for that? Yeah, we do. All right. The reason why the 29 degrees is important is because the 29 degrees is telling you that this angle is 29. So what does this angle inside of this triangle have to be? So 180 minus 29 is going to give us 151. So we know this angle is 151. And therefore, we also can solve for angle B, right?
Yeah.
So angle B is found by 180 minus 151 minus 15, which gives me 14. So we know that angle B is 14 degrees up here. Okay. All right. Thinking about what I have here. I have all of my angles and I have a side. What could I use to solve for this law of sines? We're going to use law of sines. Reason why I can use law of sines is because I have an angle and its opposite. Did we see that? I have an angle and its opposite side. So we have angle 14 and its opposite side is 1,300. So that gives us sine of 14 over 1,300 equals, and now we're trying to find this missing piece, right? So if I want to find that, that means I got to use angle 15. Agreed? So I have sine of 15 degrees over, I'm calling this A because I'm on part A, by the way. And what do I need to do to get A? And how do I solve it out? There we go. Cross multiply and divide, right? Good old equal, cross multiply and divide. So we're going to get that A equals 1,300 times the sine of 15 divided by the sine of 14. This is my exact value, but I'm going to need to find the approximate. So I type all that in the calculator. Do y'all need to see me type it in? Are we good typing? There we go.
I think it's weird that you have to turn your calculator on.
On the computer?
Yes.
All right. So make sure 1,300 sine 15. I don't know why I put 10 there. Close parentheses divided by sine of 14. Shh. Okay. And there we are. Did we all get that? So we're going to say we're going to round to the nearest thousand. So 1,390 and 799 thousandths. If you want to write that, go for it. All right. So we answered the first part.
Yeah,
There's two. So this is just how far we found it. Boom, bam. That's A. A is done. Now we're on to B. It says, what is the closest the ship will come to the buoy? Okay. What is the closest distance to anything? How do you get there? What's the fastest way? Shortest distance? Straight, right? The shortest distance to anything is to go straight, not diagonal, but you want to be perpendicular to it and head towards it, right? Yes, so, so if I want to get here, I need to know this value, right? So I need to figure out this because that is going to be my shortest distance to the buoy. Okay, so this is what part B is asking us to solve. Okay, so now I have a right triangle. From part A, we now know the value of this, right? That value is 1390 and 799. Uh-oh. Go away. Okay. I'm just going to pretend you're not there.
Look at the bottom, there's like an arrow.
Oh, yeah. The bottom. I mean, that works too. That was the top. Now stop.
See it.
Maybe we should sacrifice it.
All right. Just do that. All right, there we go. Good job. Okay, so this is just simply what now at this point? If I'm looking for this and I have this angle, we know that this is written horribly, but 29 degrees. It's a what? It's sine. And you technically can use either one, right?
But we won't.
You can either use sine ratio or law of sines. Guess what? Either one is going to
We'll just use.
work, huh? So sine ratio is sine of the theta equals opposite over hypotenuse. Yeah. So here, reason why, we have our hypotenuse and we're looking for our opposite. So sine of, so for part B, we're going to just use a sine ratio, which is going to be sine of 29 degrees equals your opposite over your hypotenuse. And our hypotenuse is 1,390 and 799 thousandths. So to solve for B, so B equals what? Is approximately, not equals.
1,399 point. Oh, approximately. Oh, never mind. I'm sorry.
Yep.
I don't have a calculator. Never mind. I do have a calculator.
So the calculator, you're multiplying, right? So what do we get? Perfect. 674 and 273,000. So B is answered.
Is that a 4 or a 9? It's a 4.
It's a 4.
Interesting.
All right, part C. So part C is a little tricky in terms of words. It says, how far must the ship go from the second sighting point to this closest point of approach? Okay, so just making sure that you understand, it's asking how far from here to here. Does that make sense? So this is what C is asking you to find. C is saying, what is the different distance I must travel to go straight to the buoy? Okay, pretty simple, right? So you have a couple options here. You can use,
Oh, Daniel. Yes, you can.
I mean, you could.
The same thing as the,
Yes, so you can use a cosine ratio. And again, Daniel, you can totally use law of sines. Okay, you have your adjacent and your hypotenuse. Okay, so then we have cosine of 29 degrees equals, and we're looking for our adjacent over our hypotenuse. So therefore, we plug in the calculator, we get C is approximately. Yes. And which way did you do it? You did law of sines. So you could have done law of sines. You could have done cosine ratio. You also could have done Pythagorean theorem and still got it. Because it's a right triangle. So all three of those would have worked and got you to the same conclusion that your 1,216 and 420 meters. They all work together to get there. Okay. All right. How do you feel about example 2?
Terrible. Really bad.
Don't be.
I just need to do the notes from last week. I haven't had time this weekend because I was out on a Boy Scout thing, but As soon as I get home tonight, sure.
Oh, if you haven't did 10-2, you're definitely like,
I get 10.1, I get all that stuff, I'm like, okay, I know that,
Yeah.
but 10.2, yeah.
all right, here we go. So it says the pitcher mound on a standard baseball diamond is 60.5 feet from home plate. How far is the pitcher's mound from first base? Okay,
Same.
it is not the same, and the reason being is because it's not a square, it's a diamond, which means that
But they're all, yeah.
that's what the problem said. So here we go. It's not perfect here. I don't know. We're gonna solve the problem as it was given. So we're wanting to know from the pitcher's mound. So from here to here to first base. Okay. All right. So you know at the home plate, based on our drawing, that it does split our 90, right? So this is going to be 45. Cannot assume that it's a right triangle. We cannot assume it's a right triangle.
I'm going to assume.
We cannot assume. All right. However, I don't need to assume it's a 90 because I have enough information to use another rule. Okay. I have a side angle side situation here. And if you have side angle side, what law can I use? Cosine. Good. We can use laws of cosine. We can use laws of cosine. Okay. So we can use laws of cosine. I'm going to go ahead and like label what I have. So I'm going to label what I have. So I'm just going to go, I don't know, A, B, C. Is that cool?
Sure.
So we're going to let this be A. We're going to let this be C. And then we're going to let this little be B. Okay. So I'm looking for side A. Because I'm looking for side A, when I set up law of cosine, there's a couple ways you can write it. You either can write it already solving for the X, or you can write it solving for with the angle, then move things around. We're going to write it solving for the X already. So that would be A squared equals B squared plus C squared minus 2AB cosine of A. Fudge sickle, 2BC. Thank you. There we go. And now I just got to plug everything in, right? So we're plugging everything. We do not know A. We're calling that's our X, our unknown, right? B is going to be 90 squared plus C 60.5 squared minus 2 times 90 times 60.5 times the cosine of 45. So this is what X squared equals. So I'm going to go to my handy dandy calculator because there's no way I can do that any other way. So we have 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times the cosine of 45. And we hit enter. So we end up with 40,000, 4,059, and 857. Okay. All right. Now what I need to do is just find X. I'm going to take the square root to find the value of X. So X is approximately. So I'm going to go second square, arrow up, grab the value. So we get 63 and 7.
Is that a 3 or a 5?
It got a little funky. It's a 5. And that's the approximate value. Okay. So unless it tells you that something is a right triangle, do not assume and use other options. Okay,
Please tell me that's it. Is
all right,
that it?
that is it.
That is it? I'm face sweating.
Yeah.